in this lecture, I want to be talking about semantics and discourse. And I know that a lot of you here in this room are interested in discourse analysis and various flavors of discourse analysis. So I would like to go through the sort of basic statistical tools that are available for discourse analysis and actually contextualize their use for discourse analysis. In particular, I'll be talking about collocations, and you know a lot about collocations already, keywords, and reliability of manual coding. That's where qualitative and quantitative analysis meet. So again, that type of qualitative-quantitative interface is very, very important. Some time ago, I was asked to write a chapter on the best statistical tools that are used in discourse analysis. It came out in the recent book edited by Taylor and Markey. Before I said yes, I had to clarify for myself where I would place myself and where I would place my thinking. And when I think about discourse analysis and using statistical tools in this particular context, and whether I would at all be able to contribute to this debate anything. And so this was the first sentence that I was trying to sort of put together that would sort of summarize this for me. And it would be interesting to know whether you would agree with that or disagree, and feel free to disagree. But I think when we think about statistics in discourse analysis, there is some kind of inherent paradox. Statistical analysis of discourse involves this inherent paradox. While discourse is often fluid, ambiguous, and fuzzy, statistics expects rigor, precision, and clearly defined categories. And all the fun is to resolve this paradox and find ways of resolving this paradox in a meaningful way, finding tools that will be sensitive to the sensitivities of discourse and the sort of context given and meaning-oriented features of discourse. So again, a couple of questions for you guys to think about. Well, think of a nice word, such as love, right? What sort of associations would spring to mind when you sort of see or hear this word? And what would be the sources of these associations? Would we be able to sort of trace those? So again, take a minute and talk to the people around you. Think of love. If we think about the sources of our associations, some of them are discourse, and we can sort of trace that, and love story being seen in particular texts and repeated patterns. Some of the associations are freer, personal as well, and that's why some people didn't want to share their personal feelings and associations. But when we just focus on the words as used in discourse and as captured by corpora, we have some tools that will actually allow us to do that. I already mentioned collocation, and that's the prime example of being able to see the meaning associations. So here's a poem about love, just to follow up with our task, and it's a well-known Scottish poem, a red, red rose, my love is like a red, red rose, that's newly sprung in June, so very appropriate for this type of year as well. What is more interesting from the statistical point of view is the word love being highlighted there as our node word, and some of the collocates highlighted there as well. In this particular one, the most frequent collocate is the word my, right? Just in this poem alone. Right, so I'm taking this poem alone as an example of how we deal with collocations. I've selected the poem because it repeats the word love so many times, so it is a very useful approximation in a very short amount of space. Right, so we've highlighted the word love, and it appears with the word my, but in some cases it appears with other words, other collocate candidates around it. So we already know The terminology here, we are talking about the node, we are talking about the collocation window, the span that can vary, can be 1, it can be 5, it can be even more, but then the precision of the collocation analysis then sort of becomes sort of broader and not we get some noise there. The more we look left and right, we get more noise inside the collocation window. And obviously we have our collocates, the words that appear on a regular basis with our node word. Well, when we think statistically about what we do when we want to identify collocates, we start looking and searching for patterns. And obviously, this is what the graph call tool can do for you very easily. But sometimes it is very important to understand what is happening there also from the discourse perspective and being able to draw the conclusions based on the behavior of words in texts and discourse. So consider the word my and consider the question whether my is a genuine collocate of love or whether, there is just some loose association. So is it strongly or loosely associated? In the poem alone, it appears 3 times in the company of the word love. So we have the number 3 already, right? But is it a lot or is it not a lot, right? Considering the length of the poem. Well, if we want to ask that question, we need to compare it with something, right? And in the collocation procedure and all those dozens of different statistical measures, we compare it with some sort of a baseline, right? Because we have to, if you see 3, you don't know whether it is a lot or not. You have to have a point of comparison, right? There are 3 possibilities. Well, no baseline is when we just look at frequencies, but the 2 genuine baseline possibilities. Random co-occurrence baseline, the shake the box model, and I'll talk about that in a moment. And this is the most popular. MI score is, for instance, based on this one. Or some kind of word competition baseline, where we are looking at the slots around the words and the frequency of words that compete for that slot. Right, so there would be a baseline that doesn't assume the shake the box type of idea. So there are sort of different things that we can do, but all the computations of all those dozens of association measures are based on this simple comparison. Comparison of what we call the observed frequency. This is the frequency that we observe in the corpus with some kind of reference frequency based on the baseline. Sometimes called also the expected frequency, especially in case number 2. So this is the shake the box model, right? What I can see here is the poem, but jumbled randomly, right? These are the words of the poem randomly thrown together. I've just used the text randomizer as a tool from the Stats Tools online to randomize this completely. And what you can see is that if we assume that the words are thrown together just randomly, by chance, alone, we would expect to see my and love co-occurring about once. Right? You can do that empirically, or you can compute that statistically, right? But you can sort of actually see this happening when you sort of just jumble the words so many different times. On average, you will see my and love co-occurring in this particular poem once. So 3 is more than 1, right? So we already have a baseline. Say, okay, so maybe my is an interesting, strong collocation of love because it appears more frequently than we would assume by chance alone. Right? This is chance alone. This is the baseline. Right? Shake the box model because we imagine that every word is written on a tiny card. We put all the cards in a box and we shake the box properly, and then we just end up with this. Right? It doesn't read like a poem. It is not a poem. Right? Probably some kind of avant-garde style poem, Dada poem, but not the poem. Certainly not a love poem. So this is what we can do empirically, or we can just use this simple formula to calculate the expected frequency, right? And this would give us 1, just about 1. Right? When we look at the frequency of the node anywhere in the corpus, frequency of the collocate anywhere in the corpus, right? And then divide that by the sample size, so number of tokens in the text or corpus, right? Association measures, and you are probably familiar with some of those. This is there just for purely aesthetic purposes. You might be able to recognize some of your favorite equations. This is Mi2, Mi3, sort of variants of Mi. This is our favorite log likelihood for some Z-score. The dice coefficient implemented in the sketch engine and its cousin log dice, and delta P, bidirectional association measure, log ratio, and we can look at others such as Cohen's D. Okay, so quite a range of those. These are the equations, but they are not important for you to remember. There are tiny numbers there. Again, I provide a full list in the book, and they are also all implemented in GraphQL in the Langsbox tool, so you don't have to remember them. Langsbox will remember them for you. Right? But just to show the variety of equations that can be used, the take-home message is there are many. If we think about the basic tension when we are identifying collocations, we usually tend to think about exclusivity and frequency as the two major dimensions. Obviously, there are many more dimensions to collocation. And if you sort of draw these lines, you can see the infrequent words or collocations, frequent collocations, exclusive and non-exclusive, and some examples. And also association measures placed in this graph that tend to identify collocations of that type. For instance, MI score and MU tends to identify exclusive collocations, so they are high on exclusivity but low on frequency. Right? So that's why MI score needs to be often also used in addition to a frequency filter. Otherwise, lots of spelling errors will be identified using the MI score. They are exclusive, they are, uniquely wrong, and also a lot of terminology, words that are not that frequent but belong to each other. Right? Something that Dana mentioned in her lecture. Log dice, MI2 usually sort of try to balance this, and that's why a lot of lexicographers use those measures. The sketch engine, the #1 lexicographers tool, would implement that by default. Right? Words that are frequently appearing frequently enough, but are also quite uniquely associated, and so on and so forth. And obviously, we need to go beyond the first-order collocates, and these are the collocation networks that we can be building using tools such as GraphQL. This becomes fairly easy, and we can, especially in discourse analysis, explore associations and cross-associations, second, third, fourth order associations. And usually I tend to think about this as sort of a summary of a particular discourse area. Right? You have one picture that summarizes the relationships in discourse, and this can be then further explored qualitatively. One of the things I would like to mention is the fact that we need to report all the relevant parameters for collocations. because there are so many different options that we can actually have when we identify collocations, and someone might like to replicate what we've done or compare that with their own study, right? For that, it is absolutely essential to report in some standardized format the choices that we have made on the way to produce the collocations or collocation networks. We've suggested this CPN, collocation parameter notation, that identifies the statistic, and this is an index that is based on the list of collocations in our paper. Statistic cutoff value, the span, the minimum frequency of the collocate anywhere in the corpus, the minimum frequency of collocation, that is the co-occurrence, and then any additional filters that were applied. Right? And that can be so long list of filters. Sometimes people want to exclude certain categories of words because they are not of interest for discourse analysis or other types of analysis. So CPN actually looks like this. This is the last line. This would be what you would report. This is just an example, so expand it, explain what is there, but you would have just this very short, abbreviated way, but standardized way of reporting collocation. Just under your figure 1 shows this, and you would have this in brackets, for instance, and everyone would know what you have done, for instance. Right, so this is the CPN, and you can read the original paper that explains more and provides more examples of that. Okay, let's move on to keywords, because keywords are really interesting and very important in discourse analysis. And again, there are many options. Usually in keywords, the prototypical example is that we have a corpus of interest. Very often we have compiled this corpus, and then we want to compare it with a reference corpus. So imagine this situation. We have a smaller reference corpus, but it doesn't have to be smaller than the reference corpus, but it usually is if we are thinking about a reference corpus such as the British National Corpus compared with a smaller corpus that we have compiled, for instance. So corpus of interest, reference corpus, we put them together, compare and contrast the frequency lists based on these two corpora. Again, this is something that you can do physically in the words tool in Langsbox, where you sort of drag those corpora together and you get automatic comparison of the frequency list, so you don't have to do this manually. But it's important to understand what's behind this procedure. What gets identified are 3 categories of words. Ideally, not all tools identify them fully. Positive keywords, negative keywords, and lock words in the middle. Positive keywords are keywords that are more frequent in the corpus of interest as opposed to the reference corpus. Negative keywords, on the other hand, are more frequent in the reference corpus than in the corpus of interest, and lock words have about the same type or same frequency. So here's a summary table of these notions. When we have corpus of interest, reference corpus, and then we can base the decision based on the sort of frequency. Corpus of interest, it is frequent here, but infrequent here. Yes, there's a prime candidate for a positive keyword. Conversely, infrequent in the corpus of interest, frequent in reference corpus, -1, and we have comparable frequencies for lock words. Right? And again, it is quite important to realize that there will be a large number of lock words, lots of the words that sit in the middle between these two extremes, and they are as interesting as the words that have different frequencies, right? We should be focused both on similarities, but also on differences, but also similarities, because similarities are very important. There is something subtle yet very interesting about similarities in language. Okay, again, you don't have to read the details. We have different procedures, statistical techniques that would identify keywords, lots of options there on the market. The log likelihood is the traditional one because it was implemented first in the wordsmith tools by Mike Scott, who came up with this type of procedure. So there was this traditional log likelihood and chi-square test to start with. And then there were different types of procedures, statistical procedures, recommended and suggested by other researchers. What you can see here is that you get slightly different results with different statistical procedures. This is a comparison between American and British English, the American English being the corpus of interest and British English being the reference corpus, right here. So you get a lot of words related to American society and culture. This was compiled in 2006, so you have Bush there as George W. Bush. Bush there as the American president at that time. Indeed, you have the word president as well. And you have also, different spelling variants. American spelling variants would sort of crop up quite frequently in the keywords list as well. Program, for instance, toward, that's the version of towards that would be more frequent in British English, and so on. If you look at Cohen's d, that's the one that I've tried to contemplate, because Cohen's d is a so nice statistic that takes both the frequency but also the distribution into consideration. You get words that are more stable across the corpus as opposed to the other procedures that just look at the comparison of frequencies and they don't take distribution into consideration. The S and P stands for the simple math parameter introduced by Adam Kilgariff and implemented in the Sketch Engine. So those of you who use Sketch Engine to identify keywords would be using this second option there. And I think it is interesting, and much more work needs to be done to empirically validate the results of these different statistical procedures, because obviously they have different equations, and just to show the first two, this is the log likelihood equation, this is the S&P equation, and they tap into the same reality. They have a similar construct behind them, but it is quite important to realize that they have very different assumptions and very different starting point here. So again, we have to make some principled decision about what we want to achieve and which keywords are actually useful for our type of analysis. Okay. The third area that I would like to mention is the Interrater agreement. Interrater agreement is really important because, as I mentioned, in corpus-based discourse analysis, we often deal with the interface between quantitative and qualitative, between subjective and objective, between interpretational and scientific. So this type of interface is really, really important. And Interrater agreement is a type of statistical measure or group of statistical measures that will actually help us deal with some of the uncertainty in this area. Right? Again, going back to the original idea of the paradox between the fuzzy reality and clearly defined categories, this is something that Interrater agreement helps us overcome. So we need Interrater agreement, which is an estimate of how reliable and consistent a coding is when we are dealing with what we call a judgment variable. A judgment variable is a variable that introduces a certain amount of subjectivity into the analysis. So judgment variable is a variable that involves, for instance, categorization or evaluation of individual cases. We read the concordance lines and we have to categorize them or say whether these are negative examples or positive examples of something. So in that case, we need to recognize this, first of all, as a judgment variable, and then pursue this Interrater agreement procedure. So here's an example. You don't have to read the details. What you need to know about this example is that this is a random example of the word immigrants used in British newspapers. And again, you know, we might ask the question in our discourse analysis whether these are positive or negative, right? Again, you know, we might have a more sophisticated categorization, but just for this example, let's assume that we just want to know whether the newspapers tend to talk about immigration and immigrants in a positive light or negative light. Categorization is a matter of choice because we have fuzzy reality that we need to put into discrete categories. So is it this one or the other? One or the other? And the question is it rigorous enough? So imagine that I look at these concordance lines and come up with this rating, right? Some are negative, most of them are negative, and 2 I perceive as positive. Well, is it just me? Right? Is it my reading into these, or would a different reader come up to the same conclusion? Well, you ask a colleague who is willing to help, or sort of a friend, whether they would do this independently. So you don't show them your results, but you take, if it is a small data set, you would take the whole data set and ask them to do the double coding. If it is a large data set, you would take a random sample of it, something like 10 or 20%, depending on the size and willingness of your colleague to help you out, right? They would come with, again, with some solutions. Some are similar, but there are some differences as well. And you would be able to see whether you would agree or disagree with your colleagues. Right? So yes is agreement, and no is disagreement. One is positive and one is negative. And you can do it with multiple raters, multiple colleagues. If you have more people willing to help out, then you can sort of add columns here. So, but let's just assume that we have these 2 raters in our mini discourse analysis project. Well, what we can see immediately without running any sophisticated statistical tools is what we call raw agreement, right? In how many times we agree, and out of all the times, if we run the numbers, we agree in 8 out of 10, which is 80%. So we can report there's 80% agreement between these. However, why we need something more sophisticated than that, because a raw agreement is the basic statistical measure that we can report. But what might happen, especially if we have just 1 or 2 or 3 or very few categories in our variable, is that we can get agreement by chance, right? Even if we just assigned, or a computer assigned the rating randomly, there might be some agreement between me and the sort of random assignment, which wouldn't be very encouraging, right? So what we calculate when we calculate any of those agreement statistics is we take the raw agreement and we take away from it the agreement by chance, right? Just to be satisfied that there is some robustness to the data. We might have different types of agreement statistics. AC1 is one of the some more recent ones. There will be Cohen's kappa in the same area and would do similar things and will be interpreted on a similar scale. But if we run the AC1, which has a fairly simple equation, we take the raw agreement here, plug it into the equation, and then we have a specific equation that calculates the agreement by chance, and we just plug it in here. Again, if you are interested in the details, the book has all the equations there and all the individual steps for calculating the agreement by chance, and we will get something like 0.71. When in order to interpret this, you need to know the scale for this measure. So occurrence kappa or AC1 range usually from 0, which is the point of random agreement. So there is some agreement. If you get 0, that means the agreement is just by chance alone. Right? You can get a negative number if there is sort of some horrible disagreement, even so beyond chance. Right? And you sort of don't speak the same language with the other rater. Right? But that would be, quite discouraging if that happened. Right? You have to go back and explain the categories again to the person, right? Usually you would be looking at this end of the spectrum and hoping that the statistic is as close to 1 as possible. 1 is absolute agreement, but we don't expect in real life, we don't expect 1, right? Because we are human beings and there's necessarily certain amount of subjectivity in the data. So we would be looking at some kind of agreement, beyond this point, or beyond point 8, which is very good agreement. In our particular case, we got something like 0.71. I would say, okay, there's certain amount of disagreement, but the categorization is stable enough for us to proceed. Right? If you get something over here, below these cutoff points, and again, these are not God's truth. These are conventional cutoff points that people have suggested based on social research. So again, you have to think about these. These are effect sizes, ultimately. So you have to think about, okay, who does that imply? Would I be happy still to go ahead with my analysis if my agreement is somewhere here, right? Or would I be more ambitious and recode the data and redevelop the coding scheme in such a way that it can be applied more consistently, for instance. Right? So if you are somewhere here, you definitely have to go back to the drawing board. Right? And you have to think about the categories. Right? Well, in reality, categories have fuzzy edges, and there are sort of intermediate cases and all that. But you need to have some kind of procedure that will decide, if in doubt, go for this category. So at least there's some consistency, right? So you would have to spell out all your coding principles, the whole coding scheme, as we call it, right? But let's assume that we are happy and we can sort of proceed and then apply some statistical measures, right? So that would be in this realm. Just a note about the different types of situations that you might encounter and the different types of measures you might like to use depending on those situations. Well, the conditionality for the choice of the statistical measure, which is the last column, is what type of variable you have. And now you should be familiar with the distinction between nominal variable, ordinal variable ranks, and the scale variable. Right? So we have different types of variables that we are dealing with, and that influences also the choice of the statistics. Also, the number of values in each variable. Right? Also, what we are looking at is the number of raters. Right? People who were given the same task and independently coded the data set or a random subset of the data set. Right? So the options are obviously AC1, Cohen's kappa, Fleiss' kappa here if we have more than 3 people who, or 3 and more rather, more than 2, who did the coding. And if we have different types of variables, we can go even as far as interclass correlation, because if we have a scale variable, we need to be looking at correlations rather than categorical Interrater agreement. Right? So these are the options that we have when we do the data coding. Okay, finally, things to remember. when we think about collocations, we need to recognize the plurality of association measures. There are many out there that highlight different aspects of the collocational relationship. It can be frequency, it can be exclusivity, but it can be other features, such as directionality in some cases, such as delta P. So there's no one best association measure, right? People might be still searching for the best association measure. There's no such thing as the best association measures. There are some bad ones. There are collocations that can be presented in different ways, in a table, but also as a graph in the visual form, and there are, different features of the table. The table is more detailed. Graph gives you more of the overall picture. Collocation networks are important because they go beyond the first order collocates and show us the complex associations. And from the discourse analysis perspective, they give us the aboutness of discourse, the aboutness of our corpus. It's those small mini summaries of the discourse relationships that we are dealing with, and that's why collocation networks are so powerful. The keyword procedure, in essence, is a comparison, a simple binary comparison between two word lists, one in the corpus of interest and the one in the reference corpus, but there are many different ways we can do that. And we have to remember, finally, that if we have a judgment variable as part of our discourse analysis, as is often the case when dealing with discourse analysis, we have tools such as the AC1 measure of Interrater agreement that we can use to actually be sure that our analysis is robust enough and that we are tapping into some more objective scientific reality rather than just some interpretative, subjective view of things as we read the data. So that will be all.